Next presentation is the wireless home automation technology.
Hello everybody, I'm Greg Wanschneider. To my left, Seth Blunt. To my right, Nathan Herrera, Robert Figuli, and Jeff Edwards. Our goal for this project was to develop a wireless home automation system. In approaching this goal, we first analyzed existing market technologies, seeking ways to improve upon them. One of the things we found from our research was that current systems only allow users to control electronics from within their own home. We felt that these systems could be improved by increasing the range. This becomes useful, for example, if you forget to close your garage door and if you forget to close your garage door before leaving for work. Our system would allow you to perform a status check to determine whether the door is open or closed, and then in the event that it is open, would allow you to close the door away from your home. An important aspect of our project was to define a first semester tangible goal. That goal for us was to develop a working prototype capable of turning on and off a light bulb using an SMS text message.
We chose SMS messaging because right now, for people to control something at their home, they have to have a static IP address, which is expensive, or a third-party service to track their IP address, which is either complicated or costly, and people just don't want to do that. The other thing is not everyone has 100% of internet, so this would allow people to need internet at their site where they're doing that, primarily at home. We did this by we're sending SMS messages from your own phone to an XB Arduino Uno device that then sends out XB commands to different devices in your home so that you don't have to have any other infrastructure wiring. We want to be able to just plug in both devices and they work. We met our first semester goal by turning on one device and turning it off, and so we expanded that to 4 lights we can turn on and off. We're using lights since that would represent anything else we turn on. And then also polling, so you can send a message to see what the state is of a light, if it's on or off. And the messages are complicated, and so we wrote a small app, so instead of having to type a complicated message, you just press a button, turn on or off a device, and see the state of it. Another thing that we ran into towards the end is security. Anyone could send a message, turn on and off your device, and so what we did is we added a lock feature, so you hit the lock button, and it only receives messages from, accepts messages from your phone. Next semester, on our way, I'd like to expand this, is controlling more devices and communication. Our goals for next semester will be able to turn on and off a coffee maker, a light or a fan, and then sense if a garage door is open, and then the ability to close it. We'll leave opening it up to the individual user if they want to allow that to be open, since that is a security issue. As for our group, since we asked, I was a computer engineer, the rest of my electrical engineers, so I did the programming, and then all the hardware was up to them. Greg was our main person doing research, market research. Is this a good product? And some of the devices to use. The other 3 are people who actually wire things up, decide if it works, and build our boxes. And if you need more specifics, they can answer. Any other questions? Yes, sir.
Try to convince me again about the choice of SMS. I understand the issue of dynamic static IP address. But the choice of SMS means that this device, I need to pay yet another wireless bill.
Yes, right now, yes, you will have another wireless bill. Some people, it's very cheap because they can add it to them. This is another thing I would like to do next semester is just go ahead and upgrade to a stronger controller, and that way we can do multiple communications and Wi-Fi, so that you can do either one. So it's really for people that want to be able to control their home, and especially if they don't have internet, or let's say you have this, you use it at home, turn a coffee maker, and then you go on the road and you want to be able to still use it. You wouldn't have to reconfigure everything or make sure you have internet. You just plug this in at a new place and it's working. And also with SMS messaging, if your device goes down for some time and you get sent a message, that message will be queued, and then it will, when the device gets back to connection, it will go ahead and execute those commands.
So how does it differ from extend device control?
I'm sorry?
Extend. You know that there are a lot of devices for home control, extend. You can buy and plug it and then control devices at home, right?
Yes, right now on our Arduino Uno board, because of its limited power, we just went with ours. Next semester, we want to go and try if we can get our hands on a Raspberry Pi or another thing like that. We would like to start implementing control of the existing hardware. So if you have an off-the-shelf thermostat that communicates over the Zigbee protocol, we would be able to extend that to our device.
Same question. What is your performance benchmark that you're going to use to define your success?
Yes, this semester was a turn on and off one light. We were able to do that. So next semester, we want to be able to control the three things, and that is turn on and off any device, whether it's light, fan, whatever. The second one is garage door opener, and be able to see if it's open and then close it. And then the third thing we want to be able to do is turn on and off a coffee maker. It's a little bit different because those are soft button controls. They're not turning on the power to the coffee maker. We're actually going to have to turn on the function of the coffee maker. Remind there's one button you push to send the command to turn it on.
So there is a certain amount of power or wattage for the external device that we control.
Because our board that we're using to control it is limited to 35 watts, but as for higher power devices, we just send out a 90-volt signal to another relay that supports the power needed for that. So the lights we have out there currently supports 110 volts. Those light bulbs there are, I believe, 60 watts.
Any other questions?
So you have to be physically present, or you get a visual from someone else? Is it a device that you have to be standing in front of the garage?
No, so you have the phone with you, and you send the message, and when you send the message in my garage door, when I press the button, it will send a text message back to you telling you the state of it.
I know this is tough. I mean, ideally, you would want your device to tell you the garage door's open, but then just to sense that you're gone. You could possibly look at your door lock or something like that. If locked, do you have the capability of sending you an SMS message?
Yes, I'm sorry. Right now, currently, you're able to pull. So if you press a button on the app for, like, to turn on the relay, it responds back to a message telling you that the relay was turned on, and it also actually sends back all the data for all the relays to make sure they're on. So the same thing would happen when the switch on the side of the garage, what we're thinking would be raised up. At that point, it would send a message telling you that the garage door is open. You could send it out when the garage door is open, or you could have it to where it's pulling it. You have to send a manual message.
So we hope you'll have a little video of this thing actually working in the senior design too.
Yes. Yeah.
It's actually working.
Yeah, this semester we have our lights set up out here. You can send a text message from your phone, turn them on and off. And then next semester, yes, we'd like to be able to demonstrate those three things.
Thank you very much.